images if we like. Okay. So who can give me an example where they would want to use a Docker image and not their operating system? Yeah, exactly. Yeah. We can try and do something very interesting. Sudo rm. I see some people smiling. Yeah. Delete the operating system. You shouldn't run that. Okay? But you can do that on a Docker image and see what happens. In other instances, if I was in a system where I didn't trust the wireless or things or the network, I don't want to run things on my operating system, so I bind everything and I just simply work on containers, and once I'm done, I delete and kill those containers, and I don't damage my file system. Okay? Because I don't trust those particular commands or whatever that I'm running. So you can see how quickly you can experiment, run things, and do stuff. So so here we could do so this one lives in home sample. Just by doing that, you can see that by doing cat, it outputs what it is that I wrote, and that file only lives in that particular container. This one. So, which one did you have last? That's it. So you can get them all. Let's go on. So what we've done is that we're trying to revive that container, and we can see that things have persisted. But as you can see, and some of you will have observed in their interactive shell, is that you can get a lot more images persisting every time you're doing the run command. Okay, so enter there rm for remove. So again, you can see we're making heavy use of existing tooling or sort of standard to operate. So rather than create a whole set of new commands, you're simply using Unix-like commands. So by saying docker run interactive -rm alpine bash sh, what will happen is that I'll run my container, I do all that we've done, but when I say exit, that container is wiped out, it's gone. It doesn't persist, it doesn't idle around. Okay? So you can see a few different ways of doing the same, particularly where you have existing containers, you can say docker stop that and then remove it with the rm command, just the same way we would delete a file. Yeah. So remember again, and this is important, everything in Linux, Unix is a file, including these Docker images. They're actually files. Yeah? Which is a really, really nice and interesting concept. Yeah? So we can remove them just like we can do. But there are also processes. But remember what I said about in Linux, Unix, processes also are viewed as files. So here I'm stopping a process, and then I'm removing it as if it were a file. Okay? So the next thing that we might want to cover, and some of us struggled with yesterday, is this concept about mounting or binding our working directory with an existing Docker container. So often what will happen is that you will have files in your system. You now have this Docker image that contains all the tooling, and we want to process files that are persisting in our operating system. Okay? So what we want to do is to bind them using -v for volumes, yeah, to the path. And you know, they say there's a specific way to do it. So the first two commands, before the colon, is directly on your local machine. Okay, and the next one is directly on your container where you want to mount your working directory. Okay, so I want to bind my working directory where my files are stored to a file on the container, and then I can issue commands within the container, right? And when I do a save or whatever, it's actually now going to persist in my local directory. Okay, so that's sort of the bridge that we want to make. Okay, so we've got a task here. So in your home directory, you may want to create a folder called Docker Share, assuming maybe that's a folder that you want to store or mount your directory. So potentially I might want to do that, you know, in a specific working directory in my analysis, where I want to use that to mount, or I just use my data file or data folder to mount it to a container. Okay. So if you create that file, okay. If you create that file in your home directory somewhere, and then this time round we issue Docker with a command run IT interactive bind to a TTY terminal and --rm. We are telling Docker once we exit, please remove this image as well. And -v mount my user directly in my home folder onto home, right? That is on the container, okay? And run the Alpine image and run the sh, the shell command. Okay, are we good? Do we understand what's happening there? Okay, so let's try and do that. Okay, I'll try and replicate that on my home folder. Exit. Okay, I got my Docker Share file here. I'm just going to delete this file because I planned the tutorial before it did. Okay. So what we're going to do is we're going to do Docker. We're going to issue the run command. We're going to do this interactively to give us a shell. We issue the RM so that we don't have any dangling containers, and we want to mount our file system. There is, if you're on Linux, you may know this command here that expands to that Docker Share. Yours may be a little bit different, and hyphen, is that colon, and I'll mount it on home. Okay, and then the image that I want is Alpine, and the command that I want to run lives in bin sh. Okay, so this command throws me to an interactive shell. Okay, and now what has happened is that the local directory Docker Share is now connected or mounted on home in the image. So no prizes to guess what will happen when we store something in home. Yeah, it'll actually persist in our Docker Share directory, isn't it? So let's try to do that. Right, cd home. Okay, I'm in my home directory. I'm gonna do cat and run this command here. Or if you like, it's vim or vi test.txt insert this file is created within the container and should remain within the shared folder once we are finished. Okay, quite a sentence. Okay, and once I'm done that, I'm using vi, so I'll issue the command to write and to quit. Okay, I'm still within my Docker image. Okay, so I'm running an interactive shell command, and I've created and edited a file in the container. Okay, the difference being that before I ran this image, I bound a specific file on my local directory onto a folder in the container. Okay, so this time round we issue the command exit, and if we check in our home directory now, we actually have a file called test.txt. Okay, and we can examine its contents. I'm gonna use the ls command. So my container is gone. Okay, and now I got this file created and persisting in my home directory. Okay, it also means that if I copy a file into my home directory, okay, and I mount it, it will be visible in the container directory. And therefore, if I got commands there, I can run them in the image, and the output will persist locally. Okay, so there's an extra step here that makes use of a more general way of doing this, because in some instances we don't always know where we are, or the path may be long, or you may be working on a file system. So if we print working directory, right, and we bound it using that variable, that will always print our working directory. So it doesn't matter where we are working. We can always mount that file or that directory onto the container's home and execute our commands. Okay.
The same thing. You have like containers and you have like create
Yes. Control D. So that kind of gives you a primer to what we done, and here is sort of a nice summary of the commands that we ran and that we can get familiar with to get us started with Docker and to just get the gist of it. And we've only used very limited set of commands. Okay. In the documentation, just one moment. What I've done is that I created a link to this tutorial that you can, if you go to your computer, you can, and you got Docker installed, you can get this to run. And this is a tutorial by Docker that can take you through slightly advanced case, but really interesting. So in this case, it just shows you how to install and then asks you to pull this image called getting started. So by running docker run minus dp880, which is interesting because what we are doing is that we're running a command and binding port 80 of the container to port 80 on your local file system, okay? And it's on your local host. And by doing that and having your container run, you can execute this tutorial that actually runs locally. By simply typing localhost on your browser, you can go through this tutorial. Again, more on Docker. Okay, essentially covering what we've done. If you want to, get a little bit, recap on what a container is, what's a container image, and then it'll go on to get this application. Talk a little bit about some advanced features about creating Docker images, and maybe we'll cover this tomorrow, later in the week. So for those who would like, I've posted that link if you want to follow through. I've just done it here, and I posted this link here, which is so if you go to Docker Hub, you'll get a lot more tooling of bioinformatics tools. Tooling of bioinformatics tools. Wow. So you got lots of images. You can search published images that you can download, work with, test those things. So maybe I just want to know, what a particular image looks like, or I want to install Python without installing it. I want to work, I can just get this image, put it in Docker, test things out, and I'm out. Without necessarily having them installed on my local file system. Okay, and I can do something useful with it because I can bind these ports and I can bind directories and make use of that tool. Okay, these are some sort of old tools in the sense that I see the last time they were updated is a couple of years ago, but they're quite useful utilities that you might want to install. So if you just do like catadapt 1.6, you can download the Docker image over here. Okay, mount your data file onto the data directory of the image, and then you can run catadapt. And assuming that you got this file in your in your local directory, you can run that command. Okay, easy peasy. It doesn't matter whether you're on Windows, Mac OS, or whatnot. You can do that by creating these images. So in some instances, I've come across where particular tools are really difficult to install and to set up. I don't know whether they got a few of those here. Or they are outdated, but you need them to do some specific analysis. I'm just looking for some of those that are a pain to install. I can't see any here, but some of them may be quite painful to install. Okay, and you can download these images, and you can check in Docker Hub and other resources. Now we know how to do this and to run Docker images. Correct? Awesome. So I'm going to stop there. And now that we know how to do it, we can go back to our tutorial. Now we know how to persist files. And for those who didn't get through, they can try and run that. It's still a little bit advanced, but it should be easy enough.